So we're at episode 3. We're continuing with the same question. The point we're currently at is how to make these two queries faster, right? In episode 1, we heard a door knock where Segmentary said that it can help you to optimize both the queries faster. In episode 2, we learned that there was a prerequisite that it has to build first, and we have did that. Now it's segment tree's part to fulfill its promise to help us answer the queries faster, right? So we're going to see range sum query to using segment tree. How can we make it efficient? How can we use segment to make the query efficient? Yes. So we are going to take this array as example, and we are assuming we know how to build the tree and we have built the tree. We are going to use it to make the query faster. Yes. So we have to answer range sum where qi qj is given, which is the index range. It can be 2 to 4 we want answer. 2 will be qi, 4 will be qj. Yes. Now let's take an example. Range sum 07. We have to find answer for this. We are going to traverse segment tree, and we know each node of segment tree will have couple of things. Is that right? Things will be, it will have its index, and it will also remember what exactly the range it is storing the answer for. Example, first node is storing answer from 0 to 7. Now if you look at it, our query is 0 to 7, and first node is itself saying, hey, I already have the answer from 0 to 7. Why do you want to search all below nodes? Is that right? That means this is the case where you are saying all the answers, all the elements of current node can contribute to the answer of this query. 0 to 7, all nodes can contribute to the answer. That means this itself is the answer, right? So this is what we can return directly. This is what our answer is. Now let's take things forward. Let's take a look at another query, which will be a little harder than this. Okay. Next query we're going to talk about is 0 to 5. Let's start traversing the segment tree and let's see how the intuition gets built. And it is going to be super simple. And animation will help us to understand it even better. We are currently at the first node. Its range is 0 to 7. But if you see, our query is just 0 to 5. That means we don't want all the elements here, is that right? That means we need to break down and we need to get some part from the left, some part from the right to get the final answer. Yes, and that is what we are going to do. Only some elements can contribute, not all, right? So 26 will say, go left, get the path that you want. Similarly, do for right. So let's do the part where we are going left first. Left index says, hey, my index is 1 and I'm going to store index from 0 to 3 only. I'm going to store values from index 0 to 3 only. If you see, out of 0 to 5, we got the answer for 0 to 3 directly from this node. That means we don't need to go any more forward for this because it is directly saying that 0 to 3 answer I already have. So what should happen here? It should actually say that do not go forward and I'm returning the value that I have. Yes, all elements can contribute. That means 6 is the answer for 0 to 3. What should happen next? We should go for right and search for the part which is not yet computed. Out of 0 to 5, 0 to 3 we got. 4, 5 answer we want. Let's see how things go. We are going on the right side and right side node 2 says, hey, I have answer from 4 to 7. But we don't want that, is that right? We want some of the part. So what is the conclusion here? Only some of the nodes for this range we want the contribution, not all. That means again, we have to break down this into parts and we have to see, should we go for left side, right side, both, or one or none? Let's see. When you go on left side, element is 8, index is 5. It is actually saying, hey, I have answer for 4 to 5. And if you focus on the query, we just wanted that, right? That means whatever elements in between were there, we want some of all those elements. So we can say, hey, whatever the element is, all of them can make the contribution. So 8 is going to be returned. So 20 is left is traverse. Let's look at 20 is right also. 20 is right, index is 6 and range is 6 to 7. If you see, not even a single value can help us contribute to this query. That means this is the case where no overlapping is there. Not even a single element can contribute. So we can say from here, I'm going to return you 0. What should 20 do? 20 is saying, I got left answer, right answer. I'm returning you the sum of it. And what should 26 say? 26 was expecting left answer, right answer. It has got it now. It can say my answer is 14 directly. Quickly summarize what we saw in this dry run. We said there there was a query which is QIQJ, and we are traversing the segment tree with three important details. One is index, another is SI, another is SJ. Now when we saw this dry run, we saw three cases here. Now we are trying to just list them down. First case was no overlapping case. What do we mean by that? If this is an array and if the query is QIQJ, just an assumption, just a quick example. No overlapping case means your SISJ can be here. Yes, that means not even a single element can contribute to the answer, or your SISJ element can be here. Again, no contribution. These are the cases where we don't want a single not even a single element to be part of our answer, right? So we can say this condition we want to return 0. If I ask you, how can you write the condition for this? If you have SISJ, QIQJ, that hey, this is no overlapping case. Pause the video for a while and think about it. Right. So condition can be if Sj is on left of Qi or Si is on right of Qj, that means it's an overlapping case. This is the condition, right? Now second case we are going to talk about is full overlapping case. What do you mean a full overlapping case? If your Qi Qj is this, if your query is this, and if your segment having value like these, all elements can contribute to the answer, right? This is nothing but full overlapping case. Another example is this. All elements of SSJ are going to be contributing to the answer, full overlapping. Another example is this. Another example is this. Full overlapping simply means all the elements of SISJ are actually going to contribute to the answer. Now if I ask you to think of the condition for this, again pause the video for a while, think about it for a second and see if you can come up by yourself. Right. So condition is this. If SISJ are in the range of QIQJ, that means it is full overlapping. Last and again, third case we are going to talk about is partial overlapping case. What do you mean by that? If your query is this and if your segment is this, that means some of the elements are there which you don't want to be contributed to the answer. That means you have to break them down. You have to get this answer. Another example is this, where you want only some of the elements from your segment to get the answer, right? So these are the cases where you'll have to break the segment even more to get the answer which you want. Yes. So these are the three cases which you talked about.